The apply method allows you to call a function with a given this context and arguments provided as an array. It's a powerful way to control function execution context and pass dynamic arguments. The basic syntax of apply is function.apply, then within parenthesis this argument followed by a comma, and then an array of arguments. For example, we have a function named greet which takes two parameters, name and greeting, and it returns a string that is a combination of the two parameters in the form of a greeting message. We can call the apply method on this greet function by writing greet.apply, and then within parenthesis the first argument is null, which indicates that there is no specific context, and the second argument is an array with two string values, John and hello. The apply method takes arguments as an array or an array-like object. It is perfect for dynamic argument lists or when working with arrays. For example, we have a function called calculate which takes three parameters, x, y, and z and returns their sum. We have an array called numbers which contains three numbers, 1, 2, and 3. Then we can call the apply method on the calculate function by writing calculate.apply, then providing null as the context, and then the numbers array as the argument. This returns the sum of the numbers, which is 6. On the other hand, the call method takes arguments individually separated by commas. It is better for a fixed number of arguments known at write time. For example, we have the same calculate function. We call the call method on this function by writing calculate.call, then we provide null as the context, and then we provide the three arguments as comma-separated values 1, 2, and 3. This also returns the sum of the numbers, which is 6. One of the most powerful uses of the apply method is spreading array elements as function arguments, especially when working with built-in methods and mathematical operations. Let's see the traditional array manipulation methods. If we want to find the minimum or maximum number in an array, we can create a number array with some random numbers. Then we can use the apply method of the math object's max or min functions. We can call this function by writing math.max.apply, where the first argument is null and second argument is the array numbers. Similarly, we can do it for the math.min.apply method. The result would be the maximum number 9 and the minimum number 1. In modern JavaScript, which is ECMAScript 6 and above, we can use the spread operator, which is 3 dots. Instead of writing the apply method, we can call the math.max function and pass the numbers array with 3 dots before it, which means spread the array into individual arguments. The result will be same as the previous example. Max equals 9 and min equals 1. Method borrowing allows an object to use methods of another object without inheriting them. This is particularly useful when objects share similar properties but different prototypes. For example, we have an object called calculator which has a property called numbers which is an array, and then it has a method called sum which returns the sum of the numbers in the array using reduce. We have another object called dataset which also has a property called numbers which is also an array. But the dataset does not have a sum method. We can borrow the sum method from the calculator object and apply it to the dataset object using the apply method. This is done by writing calculator.sum.apply, and then we provide the dataset as this context. The result of this method is the sum of the numbers inside the dataset object, which is 100. We can also borrow array methods. If we have an array-like object which has indexes like 0, 1, and 2 and a length property, we can convert it into an array by borrowing the slice method of the array prototype. This is done by writing array.prototype.slice.apply, and then the argument is array-like object, and the result of this will be an array containing the values a, b, and c. Let's explore real-world use cases of the apply method. The first use case is creating a plugin system, where methods can be injected into different contexts. For example, we have a plugin object which has a process method that takes a data parameter and converts it into uppercase. We have an application object which has a data property set to hello world string, and it has a method called executePlugin, which takes a plugin function as parameter, and it calls that plugin method using the apply method. The first argument of apply method is this, and the second argument is an array of arguments for the plugin method. So here the plugin method is the process method and the argument is the data. The result is hello world in uppercase. Second use case is event handling. We can apply event handlers with dynamic context and arguments. We have an event handler class which has an event property which is an object, and it has a handle event method which takes the event name and a variable number of arguments as parameters. Inside the handle event method, we extract the handler from the event object, and then we apply that method by calling the apply method on it. The first argument of the apply method is this, and then the arguments are passed as parameter. In the example given, when we create an instance of the event handler, we add a click event which takes a variable number of arguments and logs the arguments to the console. We call this method using the handle event method of the event handler instance. Let's see some more real-world use cases of the apply method. The third use case is method chaining. We can implement chainable methods with a dynamic context. We have a query builder class which has a constructor and a query property which is an array. It has a where method which takes two parameters field and value and pushes the condition into the query array. It returns the object itself so that the methods can be chained. We have another object called custom query which has an or where method. We want to use this or where method in the query builder object. So we apply the or where method to the query builder prototype by using the apply method of the or where function. Now, when we create an object of the query builder, we can use where and or where methods. The fourth use case is the decorator pattern. We can implement decorators using the apply method for method enhancement. We have a log decorator function which takes a function as parameter and returns a new function. This new function logs the function name before calling the original function using the apply method. It also logs the result of the original function. We have a calculator class which has a add method which takes two parameters a and b and returns their sum. We apply this log decorator to the calculator prototype add method, which enhances the add method with the logging functionality. Let's discuss the performance impacts of using apply method. The apply method is slightly slower than direct method calls due to the context switching. Using large arrays as arguments can impact memory usage. Modern spread operator, which is 3 dots, is generally faster for array spreading. Let's see a performance comparison. If we want to find the maximum number from an array containing 10,000 numbers, we can use the apply method of math.max. But the spread operator, which is math.max and 3 dots before the array, is faster in this case. Let's discuss some best practices. Use the spread operator for known array lengths. Reserve the apply method for dynamic context binding and cache borrowed methods for repeated use. For example, if we want to use the array prototype slice method multiple times, we can cache it into a variable called slice, and then use that slice variable with the apply method. Let's summarize what we have learned. Apply method is essential for dynamic context binding and array argument spreading. Modern spread syntax often provides better performance for array operations. Method borrowing enables code reuse across different object types. It is useful in creating plugins, decorators, and flexible APIs. Let's look at some advanced patterns. The first one is function composition using apply. We have a compose function which takes a variable number of functions as parameters and returns a new function. This new function takes a parameter x, and then it calls the functions provided to the compose method from right to left using the reduce right method. It uses the apply method to call each function. The second pattern is partial application, which can be achieved by using apply. We have a partial function which takes a function and a variable number of arguments as parameters. It returns a new function which takes a variable number of arguments. This function then calls the original function provided to the partial function using the apply method. The first argument is the context. The second argument is the array of arguments, which is a combination of arguments provided to the partial function with the arguments provided to the new function. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.